Alright, in this video we're going to talk about another type of reaction that's called a combustion reaction. It's basically burning things, okay? Now, chemically, when we talk about burning things, we usually referring to any chemicals, including elements or compounds, reacting with oxygen gas. Okay, so let's take a look at a few simple examples. For instance, if you just burn, like what you have watched the video of one of the experiment, or you have done it before, if you burn any metal, for example magnesium, okay, which is a solid, okay, and then if you just light it up in air, when it's going to react with oxygen, now this is going to guarantee generating you a compound between, if I ask you, can you write out the compound between oxygen and the magnesium? Right, so it's going to be an ionic compound, right? The reason is magnesium is a metal, oxygen is a non-metal. Now between the metal non-metal two elements, the compound is always going to ionic. So think about what's the charge of magnesium. That's right, the charge of magnesium in the compound is going to be +2. And think about what's the charge going to be oxygen. Just a hint, okay, by looking at the periodic table, you should be able to find it out by looking at the column numbers. Our oxygen is -2. So in other words, between magnesium and oxygen, 1-to-1 ratio is perfect. Okay, so the compound is going to be MgO. Now, can we balance this equation? Yes. All right. So the key thing is balancing any equation is you're going to separate the reactants and products. Just look at each one of the elements. Do we have the same number? Magnesium seems to be okay. Oxygen, there are 2. All right. So that's the reason, that's the way oxygen is. Oxygen gas, O2. So you need 2 oxygen here, but you can't change the ratio here. You're not supposed to. As a matter of fact, you should not change any substrate number here. So you're going to have to multiply this entire formula by 2 in order to get 2 oxygens. But that also makes the magnesium 2, so you need to go back here to put a 2 in front of this magnesium. So now you have 2 magnesiums, 2 magnesiums, 2 oxygens, 2 oxygens. So this is how you balance this reaction. So in general, okay, most of the time you don't really have a shortcut or easier method to balance the equations, even though we did actually have this kind of method in acid-base reaction and double replacement reaction. Okay, let's take a look at another one. Okay, what if you burn aluminum, which is solid as well, in oxygen gas? Now, you see if you can try the same thing with the magnesium example. Okay. All right. So first thing is you want to write out the compound between aluminum and oxygen. Again, it's an ionic compound, given that aluminum is actually type 1 metal. All right, go back to the module 5 to study more about what's the difference between type 1 and type 2 metal. Okay, so for type 1 metal, it does have a fixed charge in a compound. Aluminum does have +3 charge. Oxygen has a -2 charge always. So between 3 and 2, in order to balance the charge, okay, you can have a common multiple of 2 and 3 is going to be 6. So you're going to have 2 aluminums to make +3, that makes a +6. Oxygen is going to be -2, -2, -2, so that's -6. So the ratio here is going to be 2 to 3, so it's going to be 2, 3. Okay, or you can use cross-down method. Okay. All right, but anyway, this is the compound. Now, when you want to balance this equation, okay, I don't think it really matters. Do you want to balance aluminum first or oxygen first? Okay, but usually I would recommend students to deal with the more complicated one first. As you can see, compare aluminum and oxygen. Aluminum goes from 1 to 2, right? There's a 2 here. That's relatively simpler compared to oxygen goes to 2. There are 2 of oxygen and there are 3 oxygens. So I would deal with the unbalanced oxygen first. Now, in order to balance between 2 oxygens and 3 oxygens here, I better make them both into 6. All right, so the same thing. By making them 6, I need to put a big number 3 in front here instead of changing this to 6. And in order to changing this to 6, I need to put a big 2 in front, so I can make, now I have 6 oxygen and 6 oxygen. Whereas aluminum now is 4 over here, so I'm going to put a 4 here. So now everything is balanced for this one. Okay, so let's take a look at a little bit more complicated example. Okay, you can not only burn combusting single elements, you can also actually burn some compounds like this one. Okay, now X or Y here could be any integer numbers. For example, you can have C4H8 and burn oxygen. Now for this type of combustion reaction, okay, I can't overaddress this. The products are guaranteed to be carbon dioxide and water. What I mean is you can have any X and Y. Okay, if you have any X and Y's, look like this, carbon a number, hydrogen a number, this compound is always going to give you carbon dioxide and water. Okay, so the first thing, predict the products is going to be really simple. Now balance equation, when it comes to balance equation, okay, in this case, so the general rule, balance any equation, like I said before, try to balance the more complicated one. Now there are three elements, okay? If you look at one side of the equation, there are three elements, carbon, hydrogen, oxygen. The simplest element here is oxygen. So you won't balance this last. You can balance hydrogen or carbon, either one first. Okay, just that's the general principle when balancing equation. Okay, so let's take a look at this example. How do we balance it? Now I need to move this to the side by make it smaller. Okay. All right, so now let me rewrite this half equation here. C4H8 plus oxygen goes to CO2. Again, water and carbon dioxide are guaranteed product. Okay. Now, if I want balance equation, I want to at least separate these. Now, there are three elements: carbon, hydrogen, oxygen. We already said that. Oxygen I want to do the last. So carbon, hydrogen goes in the front first. Okay. Now let's count. Okay. There are 4 carbons. Over here, there's only 1 carbon. So I'm gonna multiply this by 4 by putting the 4 in the front. Okay. Now that makes 4. I know I'm messing up the number of oxygen as well, but that's not what we need to worry about right now. Okay. There are 8 hydrogens. Okay, there are 2 hydrogens, so I need another factor of 4 in front of water in order to balance the hydrogen. Now what you need to do with oxygen is, here you have 2 oxygen, and here you need to count the total number of oxygens. So this 4 multiplied into 2 oxygens, this 4 multiplied into 1 oxygen, so your total you have 4 by 2 plus 4 by 1 equals 12 oxygens. So there are total 12 oxygen over the other side. Now this side you need to multiply by a factor of 6. So this is how this balance equation look like. Okay, let me highlight the coefficient we already put on. Okay, 6, 4, 4. Now we didn't really put any number in front of C4H8. That means it's going to be 1. Okay. All right, so that's how you balance this equation. Okay. Now let's take a look at another example. Let's say you have C6H10 plus oxygen. Alright, so usually you'll be given a half equation like this, and then see if you can balance it. Alright, feel free to pause the video here, try it yourself. Alright, the products of course are going to be CO2 and H2O. Now when balance the equation, list out all the elements, make sure oxygen or any single elements, okay, the last one. So carbon here, 6. Over here, 1. So you need a factor of 6. Okay. Hydrogen, there are 10 hydrogens. There are 2 hydrogens from H2O. So you need a factor of 5. Alright, so 5 here. You need to make 10 hydrogens. Oxygen. You're always going to start with the 2 oxygen on this side because of the O2. Over here is going to be 6 carbon dioxide. That's going to be 6 times 2 plus 5 water. That's going to be 5 times 1 equals to 17 oxygens. Alright, so the question is how we're going to balance 2 from 17 oxygens. The simplest solution here is going to multiply this 2 by 17 over 2. So you can have 2 and 2 cancel. So you would have 17. Now this factor is going to be here. Well, obviously, typically we would like to have all the coefficients, including the first one, 1, okay, to be an integer number or whole number. So we don't want this fraction. So the only way to remove this fraction is, look at this, okay, multiply by 2 if necessary to remove any fractional coefficients by 2. So you can't change the ratio. Right now this equation is balanced. You have 6 carbons on both sides, 10 hydrogens on both sides, on each side, 17 oxygens on each side. You can't change the ratio, but you can double everybody in order to get this fragment 2, okay? Double everybody, double the entire equation. So if I rewrite this equation, okay, with the red pen here, it's going to be, this factor of 2 will be multiplied into everybody here, so it makes this 2, so makes this 17 instead of 17 over 2. Okay, makes this from 6 to 12, makes this 5 to 10. So all the coefficients are doubled. Now this equation is still balanced, except that you have twice of everybody. You have 12 carbons, 20 hydrogens, and 17 oxygens. I'm sorry, 34 oxygens. Okay, so the key point for combustion reaction is that, remember that in any combustion reaction from carbon and hydrogen, okay, compound, you can have carbon dioxide and water as products. Remember that. And then the balance of this equation usually is not that bad. Okay, it takes a little practice, but usually it's easier part once you know it's carbon dioxide and water. Okay, it's always going to be.